Hi everyone. Last class we discussed about transaction and its properties, and now we're going to discuss about concurrency control and need of concurrency. So here, uh, concurrency control, it is a management procedure. It is required for controlling the concurrent execution of the common shared data. So if one or more transactions sharing some data, so the data will be accessed by both the transactions. So we have to control which transaction have control on the data. So concurrent execution, multiple users can access and use the same database at one time, which is known as the concurrent execution of the database. It means that the same database is executed simultaneously on a multiple user system by different users. So if multiple transactions are using the data, what are all the problems may occur? So first, let me take this example. If suppose the Tx is one transaction, Ty is another transaction, Tx is accessing the value of A and performing a subtraction of 50 from that account. Then another one transaction Ty, which is also read the value of A and add addition value of 100 to the existing A value, and it's going to perform write of A. So here, before writing of A by Tx, the Ty is reading the value of A. So if suppose initially the A having the value 100, so while reading the value of Tx, the value will be 100. So 100 minus 50, it's performed. But the value is not updated in the database. So during that time, the another transaction accessing the common data, while it sees, it shows A values again 100. So it perform addition of some value. So what he expects Ty, so the value will be 200. But instead of that, the value will be different because the last update problem has occurred. So if multiple transactions accessing the data simultaneously, this kind of problems may occur. So another one kind of problem is dirty read problem. If suppose while the process is writing the data, that time another one process or transaction is reading the data, that time he may get unwanted or inconsistent data. So this kind of problem will be called dirty read problem. And unrepeatable read is also there, because once while I'm reading, the value will be one value, then after some time if I'm reading the value, it will be different. So the read will be executed repeatedly. So this kind of problem will occur if one or more transaction working on same database. To avoid that, concurrency control protocols will be used. The concurrency control protocols ensures the property of transaction, atomicity, consistency, isolation, and durability, and addition, serializability. So these for assuring this, the log-based concurrency control protocol, timestamp-based concurrency control protocol, validation-based concurrency control protocol will be used. The log-based protocols, it uses log control mechanism. Log is a kind of control for concurrent access. There are two types of logs are there on the data. One is exclusive log and the one is shared log. The exclusive log will be represented by X. So if the transaction occurred, the log exclusive, the transaction can read as well as write. So before starting the transaction execution, it must occur log. Shared log, the data item can be only read. So it requires log, yes. So log requests are made to the concurrency control manager. The transaction can proceed after request is granted. So log-based protocol, it first check the log control manager, check the incompatibility matrix, and then only granting the log. If both the transaction are requesting for read, there is no issue. Immediately the log will be granted. If not, one transaction is writing, another one transaction is requesting for reading, there will be a problem. So it will not grant the log. The same, if one transaction is reading, another transaction want to writing, so that is also not possible. If both transactions are executed for writing, that is also not possible. So based on the compatibility matrix only, the concurrency control manager issue the lock. Okay. So any number of transactions can hold a shared lock at a time. But if any one of the transaction acquiring that exclusive lock, no other transaction will be allowed to make a lock on the data item. So lock-based concurrency control protocol will work like this. Example, let me see. Uh, lock S for shared lock on item A, reading of A, and then after that unlock. Then lock S for B, reading unlock. So this kind of thing will be possible. The same scheduling with multiple transactions are executing, the lock control manager, based on the given received request, it will sanction the lock. So in this example, T1 and T2 are two different transactions. If T1 is using B, the exclusive lock, that time T2 is asking for shared lock, will not be granted because after unlocking of the lock only this can be possible. So if one transaction is reading, another one transaction is also requesting for reading, that will be granted immediately because that reading is possible. Locking protocols enforce serializability by restricting the set of schedules. Okay. The next class we will discuss about two-phase locking protocol. Thank you.